Hello, everybody, and welcome back to the Practitioners Unplugged podcast, where we dive into real-world stories and strategies of manufacturing digital transformation. Join us as we hear from thought leaders and innovators who are driving change and shaping the future of Industry 4.0. Whether you're a senior, seasoned professional, or just curious about the future of manufacturing, this podcast is for you. Today on episode 8, we're honored to have Jim Davis with us. Jim has had an impressive career spanning over 40 years in academia and industry. He pioneered AI and engineering systems, served as the first CIO at Ohio State and UCLA, and founded Smart Manufacturing to boost U.S. competitiveness. He led first industrial demonstration of a smart manufacturing platform and has been instrumental in the forming of the collaborative ecosystems and Smart Manufacturing Innovation Institute, better known as CESMII. Recently, Jim focused on collaborative ecosystems and AI-ready data strategies. Please join me in welcoming Jim to the podcast. Hi, Jim. Welcome to the podcast. Can you give us a little background about what you're doing with CESMII today and a little bit more about your career that I didn't go over in the intro?
Yeah, first of all, thanks for having me. It's a pleasure to be here. One of the first questions I wanted to answer is why would I do a podcast? And from my perspective, I've been looking at this landscape for quite a long time, and basically, there's a lot of noise out there. There's a lot of discussions, lots of things flying around, but yet there's also some very powerful technologies out there, some powerful ways to benefit manufacturers. And if I can help in any way to help people, manufacturers, the workforce, and sort that out, I'm more than happy to do so. So that's my reason for doing a podcast. The other thing, and I appreciate the introduction, but the real question, I think, from the audience is, why would you want to even listen to this guy? And again, I've been looking at this for a long time, and I know I'm an academic. I've been in the universities for a long, long time. But if you look at my background, I actually did start off with Amical Chemicals, doing some of the early digital work with PLCs and digital controllers. I spent quite a bit of time with the growth and call it the expansion of the internet. So a lot of the work I was doing was before the internet. We're now in the age of after the internet, and it plays a very powerful role. So having that background and span across how that grew, and as a CIO, I was involved with growing those kinds of technologies. If you look at smart manufacturing, it really just has simply grown out of AI, it's grown out of cyber infrastructure, it's grown out of the network, it's grown out of information and communication technologies, it's grown out of enterprise resource planning kinds of systems, and it's grown out of computation. So one of the things I can bring to the table is how to put all of these together. And what I'll try to do is kind of take you through some of the insights I have from looking across all of these different technologies, again, applied to manufacturing. So the bio is one thing, but I hope that sets the stage for a number of things I'll get into as we dive into the questions.
That's fantastic, Jim. In fact, I think given your tenure in this space, it's always helpful to look at things, step back and see how things are shaping up. You easily, have easily a 20-year perspective on how smart manufacturing has evolved over this time. Would you care to elaborate on, what it looked like when you started or when this smart manufacturing journey started? I think you coined the term around the mid-2000s. And if you were to take sort of this 5 to 10 year snapshots, what has changed? What has remained the same?
Yeah, I always find it pretty interesting to do this, although I date myself pretty quickly. In fact, I like to say I carbon date myself now. The essence here is when I started in this field, it was in the 1970s, and digital was just coming into play. So we used the word digitization, and that has progressed pretty well, and the industry has done quite a bit over the years of moving from analog to digital. What the industry has not done very well is move into what I call digitalization, which is now how do I really take advantage of digital in bigger ways? And that translates into business change, that translates into workforce change, skills. And one of the biggest areas that's in discussion today is artificial intelligence. And we did quite a few systems with industry back in the 1980s and 1990s. And we learned a great deal about how to build these systems. And we learned even back then how easy it is to build a bad system. And I'll come back to that in a few minutes. But back at that time, we didn't have the internet and we didn't have the computation. We just didn't have them. And so we were strapped. So we did a lot of so-called expert systems in the day, a lot of machine learning, understood all the math, understood the power, but it just didn't have the grounding and the capability to move it forward. Today it does. And what I like to say today is if you look at AI today, you can build a bad system much, much faster than you could in the old days. And I'll have to come back to that one in a way. But if you build the system right, the power of these kinds of technologies is huge. If you think about digitalization and how you change your business to accept data as a real asset, you accept data and how you're going to manage that as an asset, as a sustained asset in the same way as the facilities, things start dropping into place. So to me, what's changed is the technologies themselves haven't changed so much, but the capabilities for implementing them have changed dramatically. What hasn't changed over 40 years is the business mindset with which to adopt these technologies. And so one of the things I've been spending a lot of time on is what does need to change and where does this need to go? And one of the biggest areas you'll hear me talk about is if you do this by yourself, you're going to run into trouble. If you don't work together, you're going to run into trouble. And if you don't start thinking about this as an ecosystem and you find some really interesting ways, I'll talk about this a little more, about how to share the resources to your benefit and to the collective benefit, you're going to run into trouble. And it's sort of those areas that I see really starting to take hold, but they're very early right now, and the industry is really struggling with how to move forward with these. But there's some ways to accelerate and really take advantage of them out the gate, and like to get those on the table. Hope that helps.
Oh, absolutely. One of the questions that I'm curious about is, as you, again, have this broad perspective, and you've talked to different companies, worked with different manufacturing leaders, what makes some CEOs or CEOs get excited about manufacturing over others? Is there something there that, anything worth looking at?
There's a lot to say there, but if I may, let me back up just a little bit to put some vocabulary on the table and what I mean by different terms, and then that'll allow me to answer that question in a little better way. But you raised this question, well, what is smart manufacturing? And we had coined the term, but what we actually coined was a phrase. In the day, 2007, we were using the terms, what we want to be able to do is be smart about manufacturing. We want it to be predictive. We want it to be preventive. We want it to be proactive. How do we do that? We're very worried about safety and incidents. So how do we move towards zero incident? And we are very remain concerned about, we were concerned in the past and remain concerned about environmental sustainability, emissions and greenhouse gases and use of energy. So the phrase we had coined was smart, predictive, proactive, preventive, zero incident, zero emissions manufacturing. And we got tired of saying that. And so we said, well, let's just call it smart manufacturing. That's the bookends of that phrase. So that's how smart manufacturing was actually coined. But you can see where it's going. And today those terms are in wide use: preventive, proactive, diagnostic, prescriptive, all of these sorts of things. This is where the data comes into play. The other thing that's in strong play is scale. Much of what happens in the industry is machine by machine, perhaps a line operation, and it's definitely compartmentalized by company. So this word compartmentalization, I'll use that quite a bit because data are compartmentalized over a long history of doing that. And so we're actually set up not to use data very well, and we have to break through that. But we want to be able to use the data not only on just a machine or just an operation, but we want to use across the line operation, the factory. And so how do you scale the use of data across an enterprise? And enterprise going all the way to a supply chain in our particular case. So this word scale, the industry has not learned very well how to scale. And I'd like to emphasize that. So my terms and what I'll be emphasizing is smart manufacturing, how to be much more predictive, proactive, as we were saying, but also how to scale and how to take advantage of that scaling in ways that we just simply haven't done before. And I'll give you some data in a moment that shows the headroom on economic benefits by doing so is actually huge. And we have to ask the question, why isn't this accelerating to go after this economic benefit?
So Jim, on this point of smart, given that we live in a technology-enabled world, it's easy to kind of think of smart as, associated with technology. But would it be accurate to say that if I look at the Toyota production system and the lean principles that came about, wouldn't you say that's like smart, but on paper, but the principles are still valid?
The principles are still valid, but the difference is that the principles tend to be applied to an existing business model and an existing operational model. And so in that context, they're very useful and not disparaging them one bit.
Mm-hmm.
But when we talk about digitalization, we want to change the business model. And that's where we're focusing on with smart manufacturing. So yes, lean is important, but let's move into smart manufacturing and start changing some of the long-held value propositions and business models. And let me kind of dive into that a little bit. I know I'm still setting up for some of the data.
No, this is important foundational stuff that everybody
Right.
needs to be aligned on.
But the words we like to use, and I personally like to use, are productivity, precision, and performance. So you have to ask, if I'm going to draw value from data, data by itself doesn't create value in an operation. What do you have to do? You have to have sensors. You have to take that data. You have to put it into some kind of model. You have to translate that model into some kind of control system. And now you also, I'm going to argue, have to scale it. So we call that Advanced Sensors, Controls, Platforms, and Modeling, ASCPM. It's a little acronym that's been around a long time. But if you really want to monetize this, what we're seeing is so much of the discussion today is around asset management. How do I do maintenance on this particular machine? How do I create better uptime? How do I decrease downtime on a line operation? These are asset management kinds of things. And when I talk about scale, we want to move into quality. We want to move into how do I get into higher level KPIs. I want to get into things like supply chain variability, flexibility, agility, and resilience, as we're talking about. But it all comes back down to how do I translate data, number one, into productivity is one dimension of this. So productivity means how do I use my resources in the best possible way? So how can I make more? That's the numerator. And how do I use my resources in a better way to make more, which becomes the denominator? So we talk about energy productivity, we talk about materials productivity, we talk about workforce productivity, and we talk about equipment productivity. So there's a whole set of these productivities that we actually want to drive to a higher value, producing more, but using the same amount or using less going forward. So one dimension. The other one's precision. So when I make something, I want to make it to specification, and I want to be able to make it to specification first and as fast as possible. I want to do changeovers, and I want to make it to specification fast. And I also want to be able to improve that specification. How can I make that product better? And then performance is perhaps the biggest word of all. That has to do with better, faster, and cheaper. So how can I put all three of those together? So faster changeovers is a big one. What if I make a product to stock? How do I keep that stock low? We see this in the food industry all the time, right? Because if you make too much and it sits on the shelf, you just have to throw it away. So now you've wasted something. If you move into circular economies, you have some new ways of thinking about the products after they have been made. But performance also has to do with supply and demand. So if you go after productivity, right, it means nothing if you don't have the demand. So you have to go after demand. And one of the things you can do with the data now is begin thinking about demand and productivity together, or supply and demand together in new ways. And that, of course, becomes really important on supply chains and where we're going. So productivity, precision, and performance are the way to monetize these, is the way to take data and monetize it. And if you look at it across the industry, you have to do asset management in your line operations. You have to do more interoperability. So that's the line operation and the supply chain. And then you have to be able to have greater visibility of materials and flows and capacities to get at resilience and flexibility and agility at the supply chain level. So we're looking at how to scale across all those and all those levels of monetization. One last comment, and then I'll go next. But if you stay only on asset management, you're only reaping just a small amount of the benefit. If you scale, the benefit becomes much, much larger.
Could we, on the topic of on the precision dimension, could I think of that as sort of a higher resolution of data? Because with sensors, when I look at the ability to take a lot of detailed data and have a much more fine-grained view of things, because I think that a lot of, in the case of predictive maintenance, it's that higher resolution view that is also helping you detect these deviations. Is that is that a proper way to understand precision?
I think it's an important piece of it. Let me just jump to an example
Yeah.
On this one. One of the examples that we've worked in some detail on is in the semiconductor industry, and the question is quality, and wafer flatness becomes very, very an important quality issue. And it's very expensive, the metrology that they have to go through in order to determine flatness and determine that specification is very expensive. It's very staff intensive. So it's expensive on the workforce front, and it's expensive on the machine front, and to actually do that. So the question that was raised is, in fact, the metrology of that is so expensive, it's also slow. And so it's a bottleneck in the production volume sense of making more with the resources that are going forward. So the question was asked, what if we could predict, and I'm going to use the word predict in quotation marks, what if we could predict that quality specification, say 80% of the time, so I could use my metrology more selectively? And therefore, I could reduce a bottleneck and reduce a staffing component of this and still increase my volume and maintain that specification. And so we have been able to show, and it's due to the heavy work of the semiconductor industry we're working with, but the data that we can collect off an etch machine, we can determine whether that flatness has passed or failed when it comes off that machine, and that allows us to determine whether we can whether we have to use that metrology or not. We can use it more selectively and move the volume up. It's a significant way to increase the productivity while keeping the staffing constant, if you will, and you drive up the margins. So that's one example of going after the quality. In this particular case, it gets interesting just to dive in a little bit more because it gets to some of the things. We look at machine learning on this because the process of making that product is very materials complex inside that machine. It's impossible to know everything that's going on, and so you have to draw out the value of having run that machine in a in a good manner over lots of time, and we want to draw that value of what's it look like when I run this machine well versus when I haven't, because I have a lot of history with it. So that's the value of machine learning. And so we used a machine learning model to do this. And in this particular case, we had 100,000 different runs across a given machine. So we had a lot of data, and the failure rate was around 2 or 3%. So they were running it quite well. So to be able to predict a fail, actually had to really be careful with that data because the failure rate was so low, but you still could draw the value out of this with the right kind of science on that data, taking it forward. So I'm just trying to give you an example of a lot of data, but you got to prepare it right, and you can use a machine learning model to draw value, from really complex processes, complex material processes to get at a specification. And that has been done.
No, Jim, can I unpack something that you said a little bit earlier and then tie it back into this use case? But there are like three key themes that you mentioned in the intro, which was, bad systems going faster, working together in an ecosystem. So how did those three things come into play with this use case example, specifically the work together, right? So it seems like there was a big bottleneck on the metallurgy, and then there was the quality aspect in piece. And I always see this struggle between operations and quality, where operations wants to move faster, but it can't be at the detriment of quality. So when we talk about this concept of working together to do some of this stuff, what's the interoperability between the different departments in the plan and kind of generating a use case like this and bringing it forth?
Yeah, so I'm jumping into a bit more of a CESMII perspective here because we are advocates for what we call a data model or an information model for a machine. And I can come back to that, but it basically is you have to understand what that machine is doing. You have to be able to describe its functionality. You have to be able to describe the sensors. You have to be able to describe what data you want, and you need to be able to do it consistently. What we have seen in that example, but almost every other industry, I can go to an etch machine in one factory and I can go to an etch machine in another factory, and they have described the same machine differently, and they've named the sensors differently, and so all of a sudden you're now working with almost two different languages on the same machine. And so one of the things that we were able to show from a CESMII perspective is that if you bring the operations and the data folks together in that factory, they can in fact come to an agreement on how to describe that machine in a satisfactory way. And if you do that again in another operation and you have a set way of describing that, then they can do it again. And then this starts settling out to be a common way of collecting, ingesting, and contextualizing this data. That's a heavy lift that has to be understood, but it can be done. And when done, then value accrues. So that's one part to your question. The second part is you have this data consistently collected and contextualized, but you're not done yet. You have to really understand that data in the context of what you're trying to do. And so in this etch machine example, we really had to pay close attention to the noise of the data. We had to pay close attention to how to scale it because of the low failure rate, had to pay close attention to how you engineered the data because these processes all change over time. So how do you adjust for that with a machine learned model? So I call that the data preparation, or the preparation of AI ready data is what we call it. And then you have to be able to go back in and validate that. And so the operations now need to sit back and say, yes, this is validated for what we're doing. And only then, after those three major steps, can this be used with some confidence, and you know exactly the boundaries and what you're dealing with. And then, of course, you got to sustain this, which is the fourth dimension. But I hope that answers the question, because you have to begin thinking like this, and you want to put the data in a way that you can reuse it. If you lock it down and use it for one app, you've actually lost an investment.
Yeah, that's a key point that we always see, is that people approach quote unquote digital transformation in silos of the persona, right? So we have different systems for quality, different systems for power, different systems for whatever. And it seems like it does a little bit of a disservice. One of the other key things that we see is everybody now, I mean, you had mentioned that AI and machine learning has been done since the 70s. Most people are trying to move directly to it right now. So that preparation on the AI readiness is pretty critical. So how do you see people that you work with kind of balancing that? Because that preparation for AI ready data doesn't return initial value. And this is like a reoccurring theme that Sri brings up often, is this technical debt. So how do you justify, the AI data preparation side if it's not going to immediately return that value, or what does that look like?
Well, actually, if I may, I'll push back a little bit, because I believe it's entirely possible to prepare AI-ready data and start achieving some benefit quickly. What I see happening is, your point's well taken, though, because people don't take the right steps to get it processed right, and that can lead to a poor model, which is what I was saying at the beginning. But the other part of it is, how do I do this in a consistent manner, which is where CESMII plays a role with this, a prescribed structure for a data information model. And I know you had Jonathan Wise on earlier. So Jonathan Wise talked about this on a previous podcast. So the role I play relative to Jonathan is, he's worrying about how to do a consistent contextualization, how to achieve a persistent contextualization for reuse of that data. I spend a lot of my time on, given that, now how do I use it, how to prepare it, and how do I get the benefit that we're talking about. So that's how I just want to kind of clarify how we come
There's a
together.
hierarchy there.
But to your point, the A machine learned model should not be a scary thing. You just need to understand what you need to do to get to the value. And this is where compartmentalization plays a role, a poor role, and this is where ecosystems come into play. So number one, if you've compartmentalized your data, say to only a single machine, you have limited yourself on the data you have access to for that machine. And so therefore you have you have a greater probability of a poorer model because you've limited the data available. In this etch machine example, the particular company had etch machines in 5 different lines and 3 different countries. And so what they were able to do is use the information model, achieve consistent contextualization, and then what they did is they processed their data consistently across all 5 machines. And now they have a data pool that they've been able to aggregate and build more robust models across all the machines together. That's something that's not done very much right now, but yet it is, right? Because every time there's 2 operations that are similar, we all try, in a given factory, they try to compare the 2 to optimize the 2 together, and they usually use a spreadsheet. I see a spreadsheet often, to bring that data together. We're really just trying to put a consistent process together with which to look across given operations. And if you do that, you can process the data at a much lower cost because you're doing it for everyone together, and you get better data and you get better models, or you have the possibility of doing that. And that has proved to get to benefit much quicker at lower cost. So we're trying to advocate for come together on the processing of this data, and it can in fact be shared, protected. The IP can be protected. We can go into detail about that to get to these benefits much more quickly and lower cost, as I'm saying.
Yeah, I think this coming together, I see this ongoing narrative because I got started in my career in supply chain, and before supply chain was a household or well-known word, the principle we were going after is to tear down the walls between silos, whether those were functional silos, and there are also walls between the CEO and the operator, right? So I think could we say that ecosystem is also getting to that principle in removing those walls and people coming together to build models that accurately predict or at least accurately model the behavior of the system we're trying to manage? Would that be an accurate way to look at it?
That's exactly what I'm trying to say. I think you've used better words than I did. Compartmentalization is the enemy of data use in manufacturing. And it's the enemy of scaling. It's the enemy of robustness. If you're talking about AI, machine learning, or even digital twins that are synchronized with data, you need this data. You need it to flow freely. And the 40-year history in manufacturing is to compartmentalize it, is to lock it down, protect it. And what I'm really basically saying is, if you break those barriers down, and they can be broken down in a secure manner, you can protect IP, and you can still get the benefits of all of this. If I may, let me put some numbers on this. So from a CESMII perspective, we've run about $60 million in projects across about 15, I shouldn't say about, it is 15 industry verticals, just looking at a priority application that the industry has determined of value or should be of value in a digitalization space. And we've looked at paper, we've looked at cement, we've looked at steel, metals, food and beverage, pharma, oil and gas, chemical, auto, aero, semiconductor, and maybe some others that I'm forgetting as I rattle these off. So we have consistently seen, we've been keeping this data over several years now, 5 to 30% direct economic benefit, straight up. One application, 5 to 30% economic benefit. And if you average across that, 15% economic benefit. So that is in itself substantial. We've also been able to document what we call the supply chain effect. So you get the 5 to 30% on your individual factory or your individual line, but if it's part of a supply chain, and you smoothed out things. You know, things are more flexible, things are more agile, and data is what I will call more visible and exchanged in better ways. We see 12 to 15% economic benefit on top of that, called the supply chain effect. So the economics of smart manufacturing and the role of this data are very, very high. So you have to ask, what is the barrier, right? And the barrier is a long history of compartmentalization. A barrier is I'm going to do this by myself. A barrier is I've always locked down the data. I'm going to keep locking down the data. Those are business mindset changes. And I do believe those have become pretty much the most important aspect to deal with today, is to show value for a mindset change going forward. So your words are exactly right. That's a long answer to that, to agreeing.
So you have, CESMII has built this library of use cases, right? And so we should be able to readily leverage them, exploit them. And I feel like, there's a lot of customers who spend time in, chasing down, trying to quantify the use cases. You already have that ready to go. And so you jumpstart these processes, and then you're encouraging them to then spend more of the energy trying to bring the people together and, work on the use cases more collaboratively. Because a lot of the time, I think, everybody's busy doing things. There's a team that goes off, they work on a project, and then we spend all this energy trying to do adoption. We call it change management. And many times we need change management because there was no buy-in, done ahead of time. But if the conversation was more collaborative, more inclusive, then I have less of a hurdle doing adoption, right?
The answer is yes, and we've taken it a step further. I think these use cases are extremely valuable. They're valuable in a number of ways, not only the demonstration and the data that I just talked about, but they are applications that each of these industries, companies in each of these industry segments have said, I believe this is a priority application that will be of benefit to what I'm doing in my factory. And so it's not just me as an academic or others just saying, try this. It was through an RFP process, and they said, this is what we want to do. And then these projects were run to not only demonstrate the value of this application, but then to show how it would be of value and to what extent. So energy intensive companies, the value comes as a result of using less energy. For those that are not energy intensive, the value comes from better precision or better productivity or larger, higher margins, these kinds of things. But these are economic benefits across these different different segments in this way. We further have categorized what you need to do with the data. So we've already talked about data asset management. So you need to bring data together, and the more data you can bring together to bear on asset management, the better off you are. And we see this happening in proprietary ways, right? There's companies out there who build ML systems for companies, and they're able to aggregate data across different companies, and that's of huge value. We're asking how to do that at scale and across companies and in a more open fashion, in a peer-to-peer way. There is the data that has to do with interoperability. So if you have a line operation and you have 4 or 5 machines or operations that string together in a set of steps, you really want to be able to have the data and what you understand and what's happening in those operations, exchanging data better. We've looked in automotive, and they'll have 50 systems in an assembly plant, all proprietary vendor purchased systems. They're all operating in stovepipes. And what you really want to be able to do is have the data, have all of those vendors pulling off of the same data, consistently contextualized. And in many cases, you want the data being interoperable between those systems or rolled up into higher KPIs. So that's a much freer flow. It's a more open flow of the data. We've run into smaller large companies, but have lots of operations. So distributed similar operations, they want to optimize across all of these and to be able to roll things out just like we do to our cell phones, right? New app comes in, let's roll up a benefit to that. And then there's of course the supply chain, which is the same as a company interoperation, but it's now across companies exchanging data for greater interoperability. And then there's the resilience piece, which is almost a data visibility matter. Because if you can share how the supply of materials that's occurring within the supply chain, if you can share capacities or order loads or these sorts of things, it's all about material flow, and you can monitor what's happening. You get a better idea of, demands on that supply chain, and you can start looking at better ways of being more flexible, but certainly more agile. So those are three different ways of dealing with data that are much, much more than just a compartmentalized data store someplace.
So, Jim, one question we get asked a lot is that, the degree of change can be overwhelming. There's a lot of maturity models, thrown out there. But I think, when I look at a lot of these maturity models, the customer is asking, is there a crawl, walk, run process to, closing that gap? What are your thoughts on, when is it viable? When is it not? What have you seen, in all the projects that you've done?
Yeah, it's a really good question, and I have been jumping ahead as if everyone knows what CESMII is. I probably should take just a moment on
Please,
that.
yeah.
CESMII is a Manufacturing USA Institute. The acronym stands for Collaborative Ecosystems for Smart Manufacturing Innovation Institute. And if you want to know how it got its name, I can tell you, but it was not pretty. It was just it was not a well thought out active branding. But nevertheless, CESMII has stood the test of time, and so we refer to ourselves as CESMII. But we are a Manufacturing USA sponsored by the Department of Energy, and we have been set up to basically provide a central location for manufacturers to go to have the needed discussions, get tools, build out ways to approach this from a nonprofit organized way of doing this. So we currently have about 200 members, of which 25% are straight up manufacturers, but we have providers, integrators, equipment builders, and academia and NGOs involved. So we bring the entire community together. So to answer your question, CESMII has been running these projects, to put these demonstrations and the data together to show the value. CESMII has been putting together a set of tools that enable the reuse of this data. So these are information models. These are libraries in which to share these information models and make them much more usable. Tried it. They spend a lot of time, and again, when I say they, Jonathan Wise and John Dyke, who are directly involved with this, are working with many of the various bodies that orchestrate the standards and put these together and reach the agreement. And they're also working with an executive council of CXOs in the manufacturing industry that kind of give us the voice of industry. So between our membership and the executive council, we've got this very large voice of industry that's giving us direction on what's of benefit. So the answer to your question is there are some really good ways to get started, but there's some good ways to find that information so you're not reinventing the wheel, and the natural tendency is to do so. CESMII has been, for the past several years, going through a train-the-trainer program on how to do a roadmap. And so there's actually a very established procedure for a roadmap for a company to go through and answer the question, where am I? What do I look like before sensors? What do I look like after sensors? And then how do I need to think about this? And that's become one of the most important elements for companies just to get started, especially the small and medium companies. The larger companies, of course, have much, much greater resources. So I really, really strongly, and it's not just to put a plug in for CESMII, there's so much noise out there, and there's so many ways to get started on the wrong track or to spend a lot of money, and it's going to get wasted. There is a place to go, and there's multiple places to go to get this information, and I really advise the importance of doing so.
Yeah, I can comment on that. I just took the roadmap development course with CESMII and completed that a couple of weeks ago. And one of the big things, my big takeaways in the beginning was the amount of collaboration across the entire value chain of the company. Everything from leadership to supply chain. It doesn't seem like anybody is out. And typically when we see customers that, don't feel like they need help, it's because they're compartmentalized on the way that they approach smart manufacturing. We're going to focus on these four walls. It's a maintenance task, it's an IT task, it's an OT task, but this was a pretty extensive collaboration thing that basically showed you want to get feedback from your maturity across all different divisions and the difference the different perspective of different users outside of like the traditional things voting on it was kind of cool to see how it's perceived across the industry, and then bringing all those stakeholders together for that common mission. Again, it's often lacked. So yeah, it's definitely a pretty well thought out process on how to craft those roadmaps.
Yeah, I think when I look back at a lot of what customers share at the Aviva World conferences. Across the board, everyone talks about a journey, that they're going through, and initially there's a struggle to even figure out where am I on this journey, right? To be able to take some kind of assessment that says, and that journey also implies there's again stages of maturity, some kind of an end state vision. I want to pivot a little bit, because it's, right now we're going through this very spirited debate around manufacturing and the role of manufacturing, within the U.S. What's, again, so, you're bringing this perspective of having looked at this, let me put it this way. CESMII's agenda and mission hasn't changed, but the context is changing. And we can now think about, smart manufacturing as this, journey of getting better, getting smarter. But if we look at this in terms of there is a smart manufacturing vision that is about being globally competitive. 30 years ago, I think there used to be something called world-class manufacturing. We used to talk about that. Could smart manufacturing also provide some kind of a benchmark that says this is what is needed for me to be, competitive at a global stage?
The answer from my perspective is absolutely yes, and I'll try and back this up. So it's easy to say yes, but there's a couple of things, and I'll kind of go more fundamental and then kind of pull out into more of an operational sense. So smart manufacturing actually originated back in the early 2000s because there was such an emphasis on design and not manufacturing at that time. So I'm giving you a long haul view now again. And one of the reasons we came together, and when I say we, it was a group of 50 companies. We were really advocating for design, and product design are very important, not taken away from that, but there's huge amount of innovation and capability that is needed and required in the manufacturing of those products. And so it's design and manufacturing that we need to think about and actually address from a U.S. perspective. And that's going to be true for any country, right? So that's actually our roots. Right, is that manufacturing is important. And then the next part of this is data is enormously important and can move us forward in ways that we have not been able to. Well, when I say we have not been able to, we have 40-year history that brought us through digitization, as I was saying, and that's valuable and needed to be done. But now we have the capability and the ways to use data that have not been done before. And the question becomes how to accelerate that. From my perspective, the premise still is manufacturing is important. Now, how do we accelerate this advanced manufacturing that is data centered, and all of the benefits that we've been talking about the past several minutes, that goes to market share, that goes to trade, especially in trade spaces, within the country and international, and that goes to competitive is a tough term to really define, but market share isn't. And then many of our companies are global, and they have to ask, where is the market going to be? So the global aspects of this and the use of data have really risen in importance. And so if you put these together, manufacturing, data, new ways of doing data, trade, um, better use of resources, all of these things are all the hallmarks of smart manufacturing, and they are very, very true today. The only question I really worry about is the speed with which they're being adopted, and that is slow. And we keep asking ourselves, how can we accelerate this? Because the technology is speeding up very fast. It's faster than it used to be. Countries are investing in much more direct ways than they used to. So how do we keep that going? And so acceleration and adoption, to me, are the really important aspects, and scale. So adoption, scale, and acceleration, I think, are the really important terms to worry about now, because the benefits are there. How do we move it forward?
So, we are going through a period of structural change. What kind of questions and concerns are you hearing from, your member community? Can you give us some insight into, maybe there are no answers yet, but it would be good to at least understand what are the major questions that are being asked, if whether it's bringing manufacturing back to the US, reshoring, et cetera, et cetera.
I can come at that one several ways, so just bear with me. I'll probably wind around a little bit because the discussions are winding around.
You're allowed to be a professor on this show.
Sure, no, I wasn't going to go that far. The kinds of questions, one that comes up right off the bat is workforce. That's an important one. And do we have the workforce, and do we have the compensation structure of our workforce to be competitive? One of the things that is top of mind is the workforce itself. And there is the skills gap about how to work with this data, how to really appreciate it, how to treat it as an asset. And so that is very, very clear. But from an operational standpoint and an international standpoint, it's the competitiveness and compensation that we also need to worry about. So there's a fair amount of discussion about the labor market in other countries versus the labor market here, even assuming the skills. But from a smart manufacturing standpoint, what I was describing is, even with that semiconductor example, is that if you can really push on the productivity in some new ways, you can actually increase the margins and really whittle down that labor market concern. And that is one of the discussions that comes into play. And then obviously other labor markets becoming more expensive, and so these are starting to work themselves out. But that's a major play on this. The other one is better, faster, cheaper. And I was already talking a little bit about supply and demand, and we really need to worry about supply and demand and productivity in a global sense. So much of the market we're going after will be in international companies. What's up in the air is what those markets are going to look like right now. And so that creates what do I do next? But we know that it's going to settle out, and you're going to need to worry about that supply and demand and the data with which to deal with it in an agile, flexible, and very direct manner, and a new advanced manner going forward. And then the third one, which is really top of mind, is artificial intelligence and all it can do. And one of the things I like to talk about is there is the AI we were talking about and the machine learning that I've given you an example of that's important. So how it's used in a direct operation. And by the way, there's natural language processing, there's large language models, there's lots of different ways to use AI, and I'm mostly talking about that kind of AI from sensors and real-time operations. But there also is the matter of scaling and use of the network and using AI to do AI. And one of the things that AI is really good at is if we have data in more open formats and they're categorized and findable and discoverable, you actually can use AI to find the right data sets. You can use AI to find the right models, and you don't need to reinvent the wheel. So one of the things that came through one of our last workshops with NIST and National Science Foundation, and was a cross section of government, academia, and industry, is this very point, is that we actually haven't learned how to use the network to scale. And that becomes almost a very significant way to move forward. But we got to crawl first before you get to that. But it is a place to go because the value is gigantic when you think about it from an international standpoint. One last point is that there is an international group that has come together called IMX, International Manufacturing X, that is worrying about the ability to have data interoperability across companies operating in different international environments. And it's just at a fairly new place, and there's different policies and regulations in every single country. But to be able to tackle that in what we'd like to call a federated manner is also going to play very, very strongly, goes to AI, data, and everything we're talking about at the largest scale you can think of, which is international.
So what I like about all these different dimensions, you're laying out is that, the current conversation, I think of it as it's this discussion around how the US has lost a lot of jobs and we're trying to bring back a lot of jobs, but there is a real risk of fighting yesterday's war. And really, competitiveness or global competitiveness needs to be seen. It's a much more multidimensional problem because it's just not about, you could say that there's often almost like a caricature of a factory job. Whereas it's much more richer, right? And perhaps, it's not that the data scientists may be sitting virtually someplace else, but they are very much a factory worker, right? And trying to understand the systems, the person, giving structure to the data, the integration, how all these pieces come together. Whereas it's this, the factory job is something that, even blue collar, white collar, those designations don't really help us anymore.
I can't agree more. It's the industry is going through a process of learning how to use data, how to reuse data, how to use it in multiple applications, multiple dimensions, and those all need to come together in whatever environment we end up in, whether it be policy, regulation, or straight up competitiveness. Those all have to come together, and it's a mistake to compartmentalize the thinking. I do find when I talk to industry, people tend to go to their agenda, right? So there's a lot of agendas around asset management, but there's a lot of new agendas around supply chain. There's very little agenda around interoperability still, but it's starting to creep in. But if you don't think about them all together, they all play off of each other, and it starts at the factory floor with those advanced sensors, controls, platforms, and modeling. If you don't have that, you can't do the scale, you can't generate the data, you can't do anything. And once you get to the larger scale, you have to bring it back down to the action. What action can you take? And that's back down at the factory floor and the sensors and the controllers. And so, but you have to think about the whole string. So you got to start at the factory floor, but don't just lock down on one application in one day. Think about where am I going to go next? And it's not about get your data all straightened out before you do an application. It's figure out an application, get your data straightened out, but get your data straightened out so you can reuse it. That's the only difference. And there's lots of ways now to learn how to do that.
Maybe the silver lining in all these structural disruptions, going back to COVID, etc., it forces us to, to kind of snap out of these, siloed perspectives or these, or just the inertia, right? It was interesting because when COVID happened, it was more of the vast majority of problems were coming from outside the four walls of the factory. And I think that was the first time I started to see some realization is that we put our blinders on and we think about manufacturing or make, and the problem was actually design, source, make, deliver. And it took a crisis to break people out of that mindset.
Yeah, it was an interesting time, right? Two very quick examples. One is we work very closely with General Mills in the food and beverage area. And you may recall that they produced Cheerios and they decided to produce it gluten-free. But what that did was set up a huge supply chain issue because they needed to pull in their product from thousands of suppliers, the oats, in a gluten-free manner. And so how do you do that? And so the notion of certificates of quality were insufficient, because what was happening is the oats were coming in, getting stored in an elevator in Minneapolis. Then they tested it. If it was exceeded gluten-free levels, they had to throw it out. And so the waste could be quite large. So they proceeded to build out the supply chain, understand the data and the gluten-free measurements out to the supply chain, and working with the suppliers, throughout this. And they also built a gluten sensor. And so this the oats can come in, they can be checked in real time in an operational manner. And this actually created such a high level of productivity, as a result of interoperability through the supply chain. It's a really good example. And the other one is, you recall Procter & Gamble making, Procter & Gamble, Johnson & Johnson, and General Mills were all heavily impacted by COVID, right? Because their products all came into very high demand, and they couldn't keep up with the demand and had to find material. Turned out that those supply chains intersected. And so they found some ways and started looking at, if we could have interacted together with some of our suppliers, we could have dealt with this in some better ways. And this is what I mean by interoperability, ecosystem plays cross-company kinds of ways. And the data can be shared, it really can. And we've showed over and over.
These are fantastic stories, and all the more reason to join the CESMII community, because I would imagine all these stories are being shared, and where, again, from the practitioner's point of view, you need to put a lot of these, well-grounded principles into practice. And, CESMII has that ecosystem of people having this, there's a thriving dialogue that's happening.
So let's talk real quick about what's the plan of the future look like? Let's say, okay, we're starting to see, again, another supply chain disruption right now with tariffs and things of that nature. And a lot of companies are starting to reconsider the way that they do things. And let's say I'm immature in adopting that initial groundwork of Industry 4.0 technologies. Like, what skill set should I be looking at? What consideration should I be looking at if I'm going to reshore, if I'm going to hire new? Like, what does this plan of the future look like? To me, it looks less manual grunt labor and more advanced like manufacturing techniques and automation. But what is your lay of the land of what the plan of the future looks like?
I have my smart manufacturing hat on, and as you can tell, I'm a strong advocate for using data in a much, much better way. And as I look at this environment, what I see is going to become important are all these things we've been talking about. Productivity, precision, and performance are all going to be important, however this lands. And you're not going to, any company is not going to be able to deal with these unless they are collecting this data, beginning to use it in the ways that we've been talking about the past couple of minutes. Even during COVID, those companies which had invested in and were dealing with the data as an asset and playing with it, we're able to deal with it in better ways. I don't see a difference in that context, right? If you have this data, you will be able to do things in better ways going forward, and you'll be able to weather changes and disruptions in better ways. Probably the biggest mistake I see is to close down and not keep moving in some way, shape, or form on this data and the workforce with which to use it, and beginning to familiarize yourself with the tools to do this so you could begin changing your own mindset within a company. And I just think these kinds of capabilities will remain uh, not only important, but even more important in the kind of environment that we're in. A good example of this is the environment. We talk about environmental sustainability. I think we all care about it, right? But how does smart manufacturing look at it? Smart manufacturing looks at it as an investment opportunity, because if you can use less energy, and you just don't use the energy in the first place. If you can use fewer or less material, you basically increase your productivity. You probably increase you already are increasing your precision. You're increasing your margins, and so by using less energy and less material as a result of increasing productivity, you're costing yourself less. It has an environmental impact that's positive, but the money that's saved from just not using the energy actually is an investment to put back into whatever you're trying to do from a productivity, a precision, and performance standpoint at whatever level. We literally did this economic analysis a couple of years ago with an economist, and if there were 10% adoption of smart manufacturing across that 15% economic benefit that I was talking about, that creates about a quad energy savings over a 10-year period of time if it's 10% adoption. But the investment that's generated, it's not a cost-cutting measure, it's an investment generating capability, and it generated quite a bit of money to invest in workforce, to invest in these new technologies. But you have to get over the mindset and perceived risk of trying to drive that investment from those kinds of aspects at scale.
Yeah, I definitely think that's a good point. I mean, everybody's been looking at sustainability from the environmental pack, and depending on where you sit with that, you may or may not want to embrace it. But I do think there's a big driver for reducing OpEx and gaining efficiency by kind of reducing some of those energy spends across it. And I think we're missed on that part of it, right? Where we try to go too green, whatever, but there is a profound impact to that OpEx reduction within plants, especially in heavy industries. Like, definitely impacts the bottom line.
If I may, I'm going to repeat something I said a little bit earlier, just to make a change,
Yep.
so we can cut that out and do this. Uh, um, one of the questions that I'll just start off this way. One of the questions that had come up is, what did the COVID situation tell us? And one of the things we learned from a smart manufacturing standpoint is, some of our partners were producing products that were terribly important, and the demand went off the map. They could not maintain the production to supply them during COVID. And what we saw is, if they had the data and the visibility into their supply chains, they would have had the flexibility and the agility with which to deal with those. But and that became that supply chain effect that I was talking about earlier. But in addition, we began to see that some of these supply chains themselves intersected, and if they understood their suppliers and where those intersections were, they could work with their suppliers together in better ways that actually helped all of the supply chains and helped each of these individual companies. So one of the things I'm seeing is this scaling effect as a result of COVID, this interest in the supply chains, this notion of supply chain resilience, which to me always goes along with flexibility and agility, and the role of data and thinking much, much more carefully about the visibility and the way these supply chains work together and how data can support that.
I think one of the other considerations to that on the supply chain changing, let's say at the resource vendors now, is the data really on the manufacturing floor? Like if I switch product A that's coming into that, and it affects my models on the back end because it behaves differently, without that data, like it seems like there's a lot of time to like get back to that golden batch parameterization based on supply chain changes. So how does this like infrastructure enable the ability to use different sources and quickly come up to speed on a producing quality product?
Yeah, if I track your question exactly how you mean it, there is economic value, right, in dynamic deal in a dynamic management of a product. So again, faster changeovers, faster management of variation in supply chains. These sorts of things all go to a demand dynamic, which has value, which has not been tapped into, but has become much, much more important in this international world that we're living in, as well as within the US. So the data with which to do these sorts of things and act more quickly becomes very, very important. Another example of this is you may have a new material and you'd like to move that in, or you have a precision material for a particular product for a particular customer. How do you move those in and out of the production more quickly? And again, that leads to value if in fact you can do that. Data is key to doing this. We actually saw this was a metals fabrication, had a forging press, heat treatment, and then a great deal of machining, to get to a whole variety of different products. And one of the things they were doing was looking at the specification in the forging press, and then translating that, understanding the product, changing dynamically the heat treatment energy requirements for that. They were able to lower those costs, and then dynamically looking at how to do the setup on the machines much more quickly, and look at the maintenance and the setups more quickly to get those products out the gate faster. So those kinds of things actually have real value. Real money is being made doing that.
I think the recurring theme, Jim, who I'm hearing is let the data show you the way, whether it's about efficiency within the processes or agility and adaptation in this world where structural changes are going on. Just trust the data. Well, we'll look for quality data first, and then build the models that will guide you. So
I'd be remiss if I didn't add one point,
please.
Which is we are in an age with data in which the data and the number of sources, the volume, the kinds exceed what a human can deal with from a dashboard standpoint. So a lot of these kinds of things now move into more of an automation kind of mode, and data is key to automation. And I'm using automation in a truly economic sense because it's automation which is now allowing the workforce to work differently, not automation to replace people. But the kinds of things we're talking about and dealing with faster changes, different products, different setups, and the data that's coming in, a human being is not going to be able to deal with that volume with a dashboard in the way we're talking about. So let's move to what the new technologies can do, and let's move to what the people can do. And there's a lot of things that people can do to make this data work better in those situations.
Correct. And it's still a symbiotic relationship between the data and the human. Right?
Absolutely.
Great. I think on that note, we'll have to wrap it up. It's been a pleasure, having this discussion. Dante, any last thoughts?
No, that's all I have. Jim, is there any closing remarks that you want to leave the audience as we wrap up?
If I may, the closing is start, and you can start pretty simply, but the start means don't do it yourself. as I said before, engage with some others in your industry. There are some ways to do this, and the advantages will accrue in not reinventing the wheel. The advantage will accrue in finding resources that you can use directly, and the advantage will be potentially some opportunities for greater interoperability, greater data sharing that has benefits that we're just beginning to see come forward. But there's a lot of room for immediate benefit at this point. It's more a matter of the mindset to get started.
Now, just one last question on that wrap up. If somebody's looking for places to go out and seek inspiration that's less, let's say, driven by a vendor on trying to sell something and more community engagement, where should they look to go?
Well, I'm obviously biased, but CESMII is one very good place to do that. We have pretty easy access, and you can contact me or look at the website. There's people to contact. The other thing is there's a number of innovation centers across the country that also are on our website, which are able to show the way and actually work more directly in a regional manner. And they're set up through CESMII to really benefit the small and medium companies going forward. And then they also are bringing in resources in the state. And in fact, there's been a state manufacturing leadership program in which some funding has been directed to several states, to help do this. So there's a number of economic, workforce training, lots of different opportunities out there, state by state, that CESMII can help you locate and find either directly or through these innovation centers. And then I'm biased because I'm very familiar with CESMII activities, but the other institutes will be helpful. There's other bodies out there, nonprofits, that are doing the same thing, and it's really quite valuable.
Awesome. Thanks, Jim. And thank everybody for tuning into this episode of Practitioners Unplugged. We hope you found the stories and insights as inspiring and as formative as we did. Don't forget to subscribe, leave a review, and share this podcast with your network. Until next time, keep innovating and keep transforming. Thank you and goodbye.
Thanks, everyone.